And we start. Okay, this is going to be tighter in an hour, so I'm going to try my best. But year 13 integration differentiation is a lot. Yeah. If you see the content, it doesn't look more than the year 12, but the year 12 is just differentiating polynomials, so it's relatively quickly. What we are going to do is we are going to learn how to differentiate other functions. So year 12 is just polynomials. Year 13, you are going to differentiate trigonometric functions. We are going to use different rules like product rule, quotient rule, chain rule, implicit differentiation. So there are lots of more options to differentiate. But the uses or the utilities of the differentiation is going to be the same. So still you're going to find tangents, normals, maximums, and minimums. Yeah, it's just basically the same. The application is the same. What changes is the function that you use. First of all, we have sine and cos. Sine and cos are very simple to remember. Although the sign is confusing sometimes, you will have to think. So the derivative of sine x is cos x. So the derivative of sine is cos. The derivative of cos is minus sine. If you have a number in the x, so sine of 2x or sine 3x, the number goes to the front. Yeah. So if I'm derivating this, I have 3 sine 3x, and the number inside the sign, please, doesn't change. It doesn't go down by 1. Don't do anything strange. It's the same, just the 3 goes to the front. Yeah. The same with the cos, it will be minus 3 cos 3x. Yeah. Yes. Yeah. You should be able to differentiate this from first principles. It's not difficult. It's all in your textbooks. Some of you have seen it with me. We don't have time to do that from first principles, but you are supposed to know how to differentiate sine and cos from first principles. And it's very simple, very simple. Then you have to know well how to differentiate exponentials and logarithms. So from year 12, you know that when your function is e to the power of x, the derivative is again e to the power of x. Yeah, doesn't change. If you have a coefficient, the coefficient goes to the front, and you still have e to the power of x, 2x. If you have a number at the front, like 2e to the power of 3x, that number goes multiply, and you have this. Yeah. If you have a different number, like 3 to the power of 5x, let's say, we differentiate in a very similar way, but we have to add, I hope you remember, length of the base. So length 3. We will have the 5 at the front, the 3 to the 5x, nothing changes, and then we multiply length 3. Yeah, that's the only bit that we need to add when instead of e, my base is another number. Yeah. Logarithms. If I have 1 over x, this difference, no, the other way around, sorry. If I have ln x, we are going to derivate that as 1 over x. If we have ln 2x, for example, is going to be again 1 over x. Surprise, surprise. Yeah, so I don't have a 2 here because ln 2x is ln 2 plus ln x. So if we use the properties of the logs, let me make a space because I'm going to show you one more example. If we have ln 2x is ln 2 plus ln x. Yeah, using the properties of the logs, which means the derivative of ln 2, because it's just a number, is 0. And the derivative of ln x is 1 over x. So please remember, because it's quite common that, because in all of the other functions, if we have a coefficient, we multiply by the coefficient, like in sine or the exponentials or the polynomials, we write here the 2, but it's wrong. Yeah. If you have, for example, ln to the power of x squared, what we do is again use the properties of the logs, and we will write this as 2 ln x. And in this case, my derivative is 2 over x. Yeah. So if I have x squared, the derivative is 2 over x. When I have 2x, the derivative is 1 over x. Yes? So you only know how to differentiate ln x. If you have something with ln that is different, you will have to play with the properties of the logs, the laws of the logarithms. Yeah? Is this, I'm going fast because I think you all have seen this. Yes, everyone? a few things. So sine and cos, exponentials, and logarithms. Can we do these few questions briefly, or at least a couple of them? So this one, I would like you to differentiate this and please tell me in the chat. So what would you do with this one? So tell me in the chat. I'm going to do E and F, for example. So we want dy by dx. Can you tell me in the chat, please? You can write it if you prefer as 4 over 3 to the power of x, or 4 times 3 to the power of minus x, which will be even easier to differentiate, yeah? So what do I have there? Every time you have a coefficient, that coefficient is going to multiply anyway, yeah? It's like if it's not there. And remember how we differentiate 3 to the minus x. Times 3 to the minus x logarithm of 3. Yeah, exactly. So I have the minus, because I have the negative exponent there, for 3 to the minus x. That doesn't change, but I have to multiply by ln 3. Yeah? Yes. So I have the 4 at the front, the minus 3 from the minus x, and because it's a different number, I multiply by ln 3. You can imagine this is 4e to the minus x, for example, if that helps you. And just remember that you have to multiply by the ln 3. Anyone confused? Because not everyone is replying in the chat. I don't want to get anyone confused. So the second one, dy by dx. Remember I told you we only know how to differentiate ln x. So if we have something x, we have to rewrite that. How are we to rewrite that? Who can help me? So before differentiating, Daniel.
Could you do it so it's ln2 plus ln x cubed, and then it'll be 3 ln x.
Exactly. So I can separate these using the properties of the logs. This is ln2 plus 3 ln x. And when I differentiate, this bit is giving me 0, and this one is giving me 3 times 1 over x. Yeah, so this is going to be 3 over x. Yeah. These ones, we have two terms. We differentiate each of them. This one, we can expand the bracket and even divide by e to the power of x, and that's it. If we have time, we can come back, but I don't think we're going to have time. Is this clear? Exponentials and logarithms. Abby, tell me.
For E, can you explain where the ln 3 came from, please?
The 3, this 3 is this 3.
No, like the ln 3.
The ln 3, because when you differentiate, I delete this, but when you differentiate a number to the power of x, the derivative is the same, but you just multiply by ln 2. Always.
Okay.
Yeah, always.
Thank you.
When it's a number that is not e, ln of the number. More questions? No? We move on? Okay. Then, we are going to learn 3 rules that are going to help you to differentiate more complex questions. Are the chain rule, the product rule, and the quotient rule. Chain rule, we use it when we have a function of a function. This one is actually more difficult than the product rule and the quotient rule. Yeah, it's probably the most difficult to understand. We are going to use it to differentiate a function of a function. Most of the time, it's going to be a function to a power. So we are going to have, I don't know, sine of 3x, sine square of 3x. Yeah, we have something to a power, or x squared plus 5x minus ln x to the power of 7. Yeah, we can differentiate a function to a power. What we are going to do is, in that case, if we have a function to a power, we are going to differentiate like if it was a polynomial to a power, yeah, x to the power. So this goes to the front. Sorry, let me one else, someone else. This goes to the front, then the function goes to 1 less. So far it's normal, like when I derivate x to the power of n, but then I multiply by the derivative of this function. That's what it changes, yeah? So it's like having u to the power of 7, and u is a function. It will be 7 u to the 6, and then the derivative of that function. Yeah, you can see that. The other very common is a function of a function. What I'm going to do is to differentiate the outside function and then derivate the inside function. So I'm going to derivate the outside and derivate the inside and multiply. I'm going to show you a couple of examples and it will be clearer. Yeah? Yes, more or less. Let me use it. And what are we doing with the chain rule? We are using like an intermediate, so we are using an intermediate function. So we are doing dy by dx can be done differentiating y with respect to a middle function and then differentiating this function with respect to x. Yeah? Yeah, bye-bye, Grace, I know. So let me show you a few examples because it's going to be clear with examples. Here I have a function to a power. And we say when we differentiate a function to a power, so dy by dx, this is like having u to the power of 7. So I'm going to do 7 to u to the power of 6. So 7 to the front, 1 less. And then I'm going to multiply by the derivative of the function. So I have 7, the same function to 1 less, and then the derivative of the function, please brackets. So in this case is 6 plus 2x. And that's it. You don't have to expand. You don't have to do anything here. Yeah? Very common. Function to a power. Very simple. Power to the front, 1 less in the exponent, and the derivative. This one. Who wants to help me to do this one? It's a function to a power. So again, the same situation. Who wants to help me? Hamza, tell me.
So would you do 5 brackets sine x plus cos x to the power of 4? Then you multiply that by the derivative, so it'll be so cos x minus sine x.
Exactly. Exactly. So the 5 to the front, this 1 to 1 less, and then the derivative of this, which is cos minus sine x. Yeah? And I can do that every time I have a function to a power. Now I have a function of a function. So it's like the other situation. What I'm going to do is to differentiate the sign as sine, like if I was differentiating sine u, but then I'm going to multiply that by the derivative of u prime. Yeah, so I have to derivate the sign, if you want to think that way, differentiate the sign and then differentiate what is inside. Who wants to give it a go? Daniel, you raised your hand before, no, Daniel? Well, Daniel, sorry. Uribe, please.
Me?
Yes.
So, wait, do you differentiate sine?
You differentiate sine and keep the inside. So what is the derivative of sine?
Cos 3x squared minus 2x plus 1.
Plus 1. So
times...
you can take the sine, like if it was sine x, and then what do you multiply by?
You would multiply by a 6x minus 2.
Exactly. You differentiate the inside. Exactly. That's it. So we differentiate the outside function, keeping the inside the same, and then we differentiate the inside, if that makes sense. Is it clear, everyone? That's the chain rule. It's a bit confusing at the beginning, but you can use it every time you have a function of a function or a function to a power and you don't know what else to do. Last one. The other Daniel, Kanche, please tell me, how do I differentiate this one? It's a function of a function. So e to a something.
Would it be e cos x and then you integrate the cos x will be?
What is the derivative of cos?
Minus sine.
Minus sine x. Exactly, minus sine x. Or if we want, we can put the minus at the very front and then just multiply this. So e to the power of something is e to the power of something. Yeah, and then the something is the one that goes derivated. Yeah, so e to the power of u would be e to the power of u, but then I multiply by the derivative of the exponent. Is this okay? Everyone? Anyone confused? Okay, so this is chain rule, function of a function. Now, we have another rule, and this rule is, the quotient rule is in the formula booklets, the others are not. Product rule is when we have the product of two functions. Usually they are quite different, like a trigonometric and a polynomial, or an exponential and something else. So you are going to see clearly that you have a product. And what we are doing is, we call one u, the other v, and then we derivate both, and then we cross multiply. Yeah, so we do the derivative of one by the other by the derivative of one. So it doesn't matter which one you call and what. So let's say that this is u and this is v. So let's going to try to derivate each of them and multiply. Yeah. Who wants to help me with this one? So u is e to the power of minus 2x. What is the derivative of this one? Or raise the hands. Farah, tell me.
Would it be minus 2e to the minus 2x?
Perfect. And do you want to tell me this one too?
Okay. Would it be 5 in brackets 2x minus 1 to the power of 4,
Mm-hmm.
and then multiplied by 2?
Exactly. So I'm going to write 10 at the front, and that's it. So these are my derivatives. And then when I put them together, I'm going to multiply this u by v prime, and then this u prime by v. Yeah, and I add them together. So my derivative is going to be 10e to the minus 2x multiplied by 2x minus 1 to the power of 4. So these two together, and then plus, no, minus, because it's minus 2, minus 2 e to the minus 2x brackets 2x minus 1 to the power of 5. Yes, everyone? So you don't even need to write that u is this or v is this. You can just apply the rule straight away if you are confident doing that. So we do one more. This one. So for b. So u is sine 2x. V is cos 3x. Who can help me? Who? Amelia, tell me.
So for you, it'd be 2 cos 2x.
Perfect.
And then for v, it'd be minus 3 sine 3x.
Exactly. And when I put things together, what do I write?
You do the 2 cos 2x times by the cos 3x, add sine 2x times by the minus 3 sine 3x.
Exactly. Sine 2x. I'm going to put the minus at the front so we don't get mistaken. That's it. And that's your derivative, and that's how you apply the product rule. We have two different functions. We derivate each of them and we multiply with the other one without differentiating. Yeah? Product rule, this one is very easy. It's not in the formula booklet, but it's not difficult to remember. Yeah? Any question with this one? No? Then the quotient rule. Quotient rule, we use it when we have a fraction. So we will have a function in the numerator, a function in the denominator, and is in the formula booklets. So when you have a function u over v, the derivative is this. And it's in the formula booklet because it has a minus, this one is squared, so it's a bit more difficult to remember probably, yeah? We are going to derivate each of them and then use the formula, just that. So I'm going to call u to my numerator, e to the 4x, v to my denominator. Who wants to help me to do this one? Hadrika, tell me, what is the first one?
For u prime, it's going to be 4e to the 4x first.
Perfect. And what about this one?
And v prime will be minus sine x.
Excellent. So can you help me to substitute in the formula then?
Okay, so dy over dx would equal 4e to the 4x times cos x. X.
Perfect.
And minus sine x times e to the 4x.
Careful with the signs.
Whoops. Oops. Is it a plus?
It's a plus because we have a minus here and a minus here. So plus, and I'm going to put the e to the 4x at the front. It doesn't matter, but if not, it looks like it's inside the sign. And in the denominator,
Cos squared x.
cos squared x. Perfect. That's it. Yeah, so it's very simple to apply. One is u, one is v. Sometimes it's difficult to differentiate whatever we have here, but it's unlikely. So this is A. I'm going to do the same with B. I'm going to call u to the numerator and v to the denominator. Who wants to help me to do this one? Cousin. U prime.
1 over x.
V prime.
1.
1. Easy. So can we substitute the formula?
Then it just be
It was hot. It was a difficult angle.
V
1 over x.
times x plus 1
X plus 1 brackets. Yeah. Them.
plus ln x just plus ln x.
Careful because it's a minus.
Oh, minus ln x.
Minus ln x multiplied by 1. Exactly. Divided by?
X plus 1 all squared.
All squared. Exactly. That's it. So everyone is happy with this. This the rule is not difficult. You have it in the formula booklet. Numerator is u, denominator is v, and then you just derive and substitute in the formula. Yeah. Question, Amelia.
You know, for this last one, you know how you didn't expand the brackets? Would you be expected to in the exam, or could you just leave it how it is?
You can leave it like this. Yeah. Okay. In fact, if you don't expand the brackets, sometimes you can cancel because some derivatives are the same, like exponential. So if you have an exponential here, you will be able to cancel things. So you don't have to. No. Or expand this bracket. You mean this bracket? I would expand this bracket. I wouldn't expand this one. If you don't expand it, unless they say specifically in the simplest form, then I will be more careful on how you give the answer. If they don't say in the simplest form or write as logarithm of a number minus logarithm of another number, something very specific, they cannot take your marks for not simplifying things. Yeah, unless it's very obvious and you have 2 minus 2 and you don't subtract that. Yeah. More questions? No? All clear? Okay. Then we have a series of trigonometric functions. So we started with sine and cos. These ones, you have to know them by heart. Then you have a few others like tan, cosec, all that. But they're in the formula booklets. Yeah, so I'm going to show you. This one is the extra one because I have it open, but all of them have the same formula, don't worry. So you have, I told you before, the first principles thing, and then you have a series of, so this is the quotient formula, the quotient rule, and you have tan, sec, cot, cosec. You don't have to remember them because they are here, and because sometimes it's confusing, remember which one is the minus, which one is not, but you have to remember that they are here. Yeah, so please remember they are there, and you need them, you use them. So you ask sine and cos from first principles is very rare, Fraser. It's very rare. So not even every year or anything. They will ask you something from first principles, but it's more common that it's a polynomial than sine or cos. If we have time at the end, we can do it, but it's not common. Then what you have to know, just in case, is more or less how you can deduce those derivatives, because those derivatives are very easy to deduce. And when I mean is tan, cosec, and cot, all those are reciprocal functions, remember? And because they are reciprocal functions, and they are related to sine and cos, and we know the derivative of sine and cos, we can deduce them very easily with the quotient rule. What do I mean? If I need to differentiate tan x, even if I know that is in the formula booklet, they can ask you to differentiate or to find it. We are just going to write that tan x is sine divided by cos and use the quotient rule. Look. Yeah, it's very, very simple. What I'm going to do here, u is sine x, v is cos x. Who wants to help me to differentiate this? Come on, someone. Alex, please.
Sine goes to cos and cos goes to minus sine.
Exactly. Well done for the signs. And now when I substitute, what do I have?
You get cos times cos, so cos squared minus plus sine squared over cos squared
Which is
sine squared.
what
No,
is
no,
it?
no, it's not. Sorry. You can split it up to cos squared over cos squared plus sine squared over cos squared. And
Even easier. What is this?
that's 1.
1, exactly.
It's 1 over cos squared, which is cosec.
Exactly. Is cosec or sec?
Sec, sorry.
Sec squared. You need to remember which one is which one because it's easy to mix them. Exactly. So the derivative of tan is sec squared. It's in the formula booklets, but they might to ask you to derivate any of them. If you are asked, just remember to write them as reciprocals and all that of sine and cos and use the quotient rule. Yeah. If we need to do this one, we know that cosec is the reciprocal of sine. So we would use the quotient rule with this one. Yeah. U would be 1 and V would be sine x. If we have time at the end, we can come back. But I told you the chapter is super long. So I want to just carry on just in case. Yeah. But we use quotient rule with this one, and then we will get cosec cot. Is this clear? So if they ever ask you to deduce any of the trigonometric functions, even if they're in the formula booklets, that's how we do it. We use the reciprocals, the sine, the cos, and quotient rule. All good, everyone? Yeah? Okay. Then, I told you there are lots of things. Parametric differentiation. So hopefully, because integration is usually after parametric equations, you have seen parametric equations. If not, parametric equations is just a way of writing equations or that represent functions in the graph. Yeah. So we have x in terms of a parameter. So it's a function of a parameter, and y is a function of that parameter. And every time we give value to the parameter, we get an x and a y, and that will be a point in the plane. Yeah, and we can represent a graph. To differentiate parametric equations is super simple. So the derivative of y with respect to x would be the derivative of y with respect to t divided by the derivative of x with respect to t. Yeah, so we derivate the y, we derivate the x, and we divide. Very simple. So let's going to do this one very quickly. So we have x is t cubed plus t, y is t squared plus 1. Yeah, t is an irreal number, and we have to find the gradient at the point P when t is 2. What are we going to do? Differentiate y, differentiate x, divide, and then substitute. Can we all do it, please? And you tell me what you get in the chat. I want the final number, the gradient at that point. So dy by dx, I differentiate the y, I differentiate the x, and then I substitute the t by 2. 2t exactly. And then when I get the t, substitute by 2, I get one number. So 4 divided by 13, 4 13th. 4 13ths. Okay, excellent. So that's the gradient, and that's what I do. Be very careful with one thing. I've done it a million times. When you write parametric equations, usually the x is first and then the y. When you write the derivative, you derivate the y and then the x. I've done a million times the derivative of this one in the top, the derivative of this one in the bottom, and it's the other way around. I tell you, because I've done it. I've seen it many times. Please be careful of the order. Yeah, it's very easy to just swap them. Is it clear? Very simple, because the functions are usually going to be simple. That's it. Tell me.
Could you not like how do you explain, like, did you not make one Cartesian equation and differentiate like that, or do you have to follow this rule?
It depends. So if the question first asks you to find the Cartesian equation, for those who haven't seen Cartesian equation, the Cartesian equation is when I eliminate the parameter and then I have my function with x and y. Yeah. If I eliminate the parameter and I have an equation of y in terms of x, and they ask me the gradient or the derivative, I could differentiate that. But if they don't ask me first to find the Cartesian, if they don't ask me first, and they give me the value of the parameter, I'm going to differentiate this way. Yeah? Because I don't need to find the Cartesian, which is unnecessary work and maybe complicated, because here I have the square root, so it's not nice. I don't necessarily want to do that. And because if they give me the parameter and I have the derivative in terms of x and y, I will have to find the x to be able to substitute the point. Yeah. So if they give you the value of the parameter and find the derivative in one value of the parameter, you do this. It's much faster. Does it make sense? Does it? If you have already found the Cartesian and they give you a value of x, yes, you use the Cartesian. But usually it's easier this way. Yeah. Okay. That's a very good point. Any question? Then, and I say these questions are really, really not complicated. And many times they're going to ask you the tangent. So you find the gradient, you find the point. So imagine just a quick note. Imagine instead of asking you the gradient, they ask you the tangent at that point. The tangent at that point. What we are going to do is, we know this is the gradient, but we need to find the x and y. Yeah. So when the parameter is 2, x is going to be substituting t here. So the point will be 2 cubed plus 2 is 10. And the y is going to be 2 squared plus 1, 5. So the point is 10, 5. And the equation of the tangent will be y minus the y of the point equals gradient brackets x minus the x of the point. Yeah. So if they ask you the tangent, that would be logic, not just the gradient. You will need to find the point as well. Yeah. And write the equation of the tangent. Because we don't write the equation of the tangent in parametric form, we just write it normal. Yeah. And they will give you the information to find it out. Just a note on that. Clear? The parametric differentiation is very simple, dy by dx. Now, implicit differentiation. Implicit differentiation is when we have a function where the x and the y are so mixed together that it's very difficult to make y the subject or even x the subject. Yeah? And then we are using the chain rule, even if it doesn't look like we are doing the chain rule. So when do we do that? So let me show you. A function like this one. So I hope you can see sometimes if you don't have a big screen, you cannot see the powers. We have this function. Making y the subject, super complicated. Making x the subject, super complicated. Our equation is given in implicit form. Yeah, that's how we call this type of equation. This equation is given in implicit form, and we use implicit differentiation. We are going to find dy by dx, which means we are going to differentiate the whole expression term by term. When we differentiate x cubed with respect to x, we have 3x squared, right? We are going to differentiate, so 3x squared. When we differentiate x, we have 1. When we differentiate y cubed, because we are differentiating with respect to x, what we are going to do is to use the chain rule. And we differentiate the y, and then we add dy by dx. Yeah, so we differentiate this with respect to y, which is 3y squared. And then we multiply by dy by dx. Yeah, so this is like a function u. We do du by dy, and then dy by dx. That's what we are doing. So when we differentiate the x, completely normal. When we differentiate the y, we differentiate with respect to y, but then we add dy by dx. So can you tell me in the chat, what do you think is this one, please? So what do you think it would be the second one? If I differentiate that, what we will have? Exactly. 3 dy by dx. Perfect. So we will have 3, and then when we differentiate the y, dy by dx. And now, derivative of 6 is 0. What are we going to do? Make dy by dx the subject, and that's it. Yeah. So we factorize the dy by dx, multiplying 3y squared plus 3 on the left, everything else to the right. So minus 3x squared minus 1, which means dy by dx is minus 3x squared minus 1 divided by 3y squared plus 3. And that's your derivative. Yeah? And I'm going to do that every time that x and y are very difficult to separate. Yeah, we cannot make x the subject or y the subject easily. So we derive each term. Every time I have x, normal. Every time I have y, I have to add, apart from the normal, the dy by dx. Then I make dy by dx the subject. Easy? Everyone? Let me suggest another one that is, it can be a bit more complicated because sometimes even I have to use product rule or I have x and y in the same product or something. We have to find the value of dy by dx at 0.11, and this is the function. So please try. So we have e to the power of 2x and then y, x, y minus 2. Again, you see, I cannot make x the subject or y the subject easily, so I'm going to differentiate each value at a time. The right part is super simple. Can you tell me in the chat what I'm going to do to differentiate that? The left. So can you tell me in the chat what I'm going to use to differentiate that? So in the chat. Yeah. Excellent. I'm going to use the product rule. I have to do functions completely different, so I'm going to differentiate them using the product rule. So I can say this is u, this is v. Who wants to help me to differentiate this? And then we differentiate the whole thing. Someone? Who wants to help me? Fraser, go on. You
So
plan.
e to the 2x, and then v prime is 1 over y dy by dx.
Exactly, exactly. So when I differentiate, then y is 1 over y, like any log, but then I do dy by dx. And now I cross multiply. So let's going to go back to this expression. I have this one multiplied by this one. So I have e to the power of 2x divided by y dy by dx. I'm multiplying this by this plus this by this. Yeah. So plus 2 e to the 2x ln y. That's the derivative of the first half of my equation. What is the derivative of the rest? Derivative of x with respect to x is 1. Derivative of y with respect to x is dy by dx. Yeah, don't forget, every time is y, I have to do the dy by dx. Derivative of minus 2, 0. And now I group things together and make dy by dx the subject. Everyone? Is all clear? Minus 1. Please stop me if it's not. I know I'm rushing, but it's quite a lot of content. Yes? dy by dx is going to be this numerator divided by e to the 2x over y minus 1. Now they ask me the value of this derivative in the 0.11. Because this is in terms of y and x, I'm going to substitute both. So I'm going to substitute the y by 1 and the x by 1. Yeah? Yes. I substitute and then I get whatever I get. So in the numerator, because len y is 0, I have 1. In the denominator, I have e minus 1, no? E minus 1. And that's it. So implicit differentiation, when I have x and y, that I cannot make the subject, and I differentiate each term. The x normal, the y using the chain rule. So I differentiate with respect to y, and then I add the dy by dx. Fraser.
You know, if you didn't have one that didn't cancel out as nicely, do you just use the x and the y coordinate to actually find the gradient? You have to use both in implicit differentiation.
But that's what I did. I didn't cancel. I just substitute the 1, 1.
Oh, okay.
Yeah, so I substitute len 1 is 0, so this bit is all 0. Then I have 1, and then e to the power 2 divided by 1, and then minus 1. I just substitute. I didn't cancel.
Okay, that's fine. Thank you.
No problem. In fact, I don't think we can simplify much more this one. More questions? What they could ask you, again, find the equation of the tangent or something similar. But the important thing is that you know what to do when you have a function like this. X and Y mixed together, just implicit differentiation. Sometimes they tell you, sometimes they say, using the implicit differentiation, find dy by dx. But if they don't, it should be clear, yeah? X and Y mixed together. We have one thing here that is, it doesn't appear much more in the exams, but if it's important to know. So dy by dx is the reciprocal of dx by dy, which means if you have a situation like this one, you could use implicit differentiation and it will be fine. So can we do that by implicit differentiation? Who wants to help me? This one is easy. So can we use implicit differentiation? Someone help me, please. Who raised the hand? Abby, tell me.
Do you have 3y squared dy by dx plus dy by dx equals 1?
Exactly. So, and then I can factorize dy by dx is 3y squared plus 1 equals to 1. So dy by dx will be 1 over 3y squared plus 1. That's one way of doing it. Implicit differentiation, because I have x and y, so why not? But if you notice, the x is the subject. So it's not easy to make y the subject, but x is already the subject. Or even if I have x plus y, I can bring the y to the other side. I can use this thing here. So I can derivate with respect to y and then do the reciprocal. So I can do dx by dy. So this will be an alternative. Dx by dy is differentiating this with respect to y. So it's not implicit differentiation. I am differentiating with respect to y. So this with respect to y is 3y squared. This with respect to y is 1. So I'm derivating with respect the y with respect to y. So don't add the dy by dx, yeah? And then that means that dy by dx is the reciprocal of that, which is 1 over 3y squared plus 1, which is the same, yeah? You get the same, but if it's easy to make x the subject, it's slightly faster than doing implicit differentiation. It's up to you. If it's confusing, just use whatever you prefer, yeah? But if x can be the subject, you can do derivative with respect to y and then reciprocal, yeah? And this is something that sometimes we forget, yeah? It's not so, it doesn't appear in the exams all the time, so it's easy to forget. Clear? So we have done a lot of new things. We have done the trigonometric functions, the product rule, the quotient rule, the chain rule, parametric differentiation, implicit differentiation. Then we are going to see a bit more about the second derivative. So remember in the first half of the lesson when we did year 12 content, we were using the second derivative to find if a stationary point was maximum or minimum or point of inflection. In year 12, they add something else, which is when a function is concave or convex. This is not the most common thing that they ask you. Sometimes in the AQA questions that are multiple choice, those that are 1 mark, is a common question or relatively common, but if not, not too much. So a function is concave when it has this form, kind of a mountain thing, yeah? And it's convex when it's more like a container, yeah? The second derivative here is negative. The second derivative here is positive, yeah? So in this function here that we have, the function is concave up to here, and then convex up to here. And this is a point of inflection. Remember I told you before, a point of inflection, the function changed from concave to convex, or the other way around. So this is a point of inflection. And if you notice, the point of inflection that we saw in the year 12, let me show you, in the year 12, this one, the point of inflection that we had here, it was a stationary point as well. Yeah, so we have a point of inflection here where the function changed from convex to concave and the tangent is horizontal. So it's a stationary point and point of inflection. While this one here is a point of inflection because the curve changed from concave to convex, yeah? But the tangent is not horizontal. So this is a point of inflection that is not a stationary point, yeah? I tell you because it's quite common that you mix them. Point of inflection, stationary points sound like they should be the same, but they are not, yeah? Stationary point, tangent horizontal. The function is not increasing or decreasing. Point of inflection, the function changed from concave to convex. And they can ask you either. Yeah, so be careful because stationary point is not a point of inflection. If you have to find a stationary point, you could do the derivative equal to 0. Yeah, in the point of inflection, the second derivative is going to be equal to 0. Yeah, because the function is not concave or convex, is changing from one to another. So be careful because we tend to mix them. Stationary points. They could be point of inflection. So this one could be maximum, minimum, or point of inflection. Yeah. Or just point of inflection. If they ask you, you just do the second derivative equal to 0. Remember? You will remember? I just tell you what I used to remember. So concave, I remember thinking concave is like living in a cave. That is negative. It's not good. So just remember in somehow that concave, the second derivative is negative and it's this cave shape. Yeah. Does it make sense? It's very, it's not very common, but yeah, sometimes. And now the last thing I want to go through is these type of questions that are usually a bit wordy about rate of change. So, and this is connected to differential equations sometimes. So you have to use this this thing that we are going to learn sometimes to form a differential equation and integrate it. So you will learn this when you learn integration. Yeah. Rates of change. So when we talk about rate of change, is how quick something changes and if it changes increasing or decreasing. Most of the time, a rate of change is going to be with respect to time. So if they don't say anything, a rate of change usually is with respect to time. But they could say the rate of change of the area with respect to the radius of something. Yeah. So you can have the rate of change with respect to something else. If they don't mention, it's with respect to time. Yeah. And in this type of questions, sometimes they ask you to find the rate of change of something at a particular point, and they give you some other information. And somehow you have to connect it. Yeah. The way of connecting the information is using the chain rule. I know you are not going to be happy about it, but we are going to use the chain rule. And you will have to find a chain rule that connects all the variables that you have. And when you have questions, you won't find that difficult. My recommendation is, for this type of questions, you do first a few questions in your textbook. Instead of jumping on, I always tell you, do exam questions, 100%. But for this type of questions, sometimes it requires a bit of easy practice first. Textbook questions, I think. Let me show you a couple of them. Given that the area of a circle is this formula, we already know that, even if they don't tell us. Sometimes they help you with the formulae in these questions. And that the rate of change of the radius in centimeters per second is given by dr by dt is 5. Find dA by dt when r is 3. Sometimes they are not going to tell you this. They are going to say the rate of change of the radius is 5. That should be enough. And I would check the units. The units are always super helpful to know what is changing with respect to what. So this is going to be always d what something by d something. If you have centimeters by seconds, it's going to be length by time. Yeah. What are we talking about? Radius. Yeah. So it's going to be dr by dt, even if they don't tell you this, but sometimes they don't. Yeah. Now, we are going to substitute this at the very end. So we need to find dA by dt in terms of r, and then we will substitute. How are we going to connect these three things? With a chain rule. And this is not a derivative, but we can get easily a derivative from here. What derivative can we get from here? dA by dr. Yeah, dA by dr is 2 pi r. So we have dA by dr, dr by dt, and we need dA by dt. So we are going to write a chain rule with those. Which one is going to be that chain rule? Can someone tell me? So remember how the chain rule works. Abby, what I'm going to write?
Could you do dr by dt times dA by dr?
dr by dt times
dA by dr.
dA by dr. Yeah. Usually we don't write it this order, we write in another order, but that's completely fine. So what we are going to write is dA by dt is going to be dA by dr times dr by dt. Fraser, I'm going to ask you in a second. So these two are the same. So this is like my intermediate function. Remember in the chain rule, I have something in the middle. So I'm using this. It was like the u before. And then this one is going to be this one here, and this one is going to be this one here. So I'm using r in between. And in this case, this one is the one that I need. This one is this value here, and this one is here. Yeah, but I'm not writing this way because I need this one. I could be needing this one and then make up the subject, so it doesn't matter. So this is telling me that dA by dt is 2 pi r multiplied by dr by dt, which is 5. So this is 10 pi r. And now they ask me r, whatever. Then I substitute, yeah? When r is 3, I substitute the r by 3. When I substitute the r by 3, I have 30 pi. Area is centimeters squared. Time is, it was in seconds, no? Centimeters squared and second. And that's what I do. So I'm going to have to write one chain rule. I need 3 variables, yeah? I'm going to have one that is usually a number that they give me, one that they always ask me, and that one that I usually deduce the differentiate in a formula. It's not the case 100% of the time, but most of the time, yeah? Sometimes, I'm going to show you an example, you have to combine a couple of chain rule. Yeah, and you're going to see with one example. So Fraser, you were asking me if you integrate something. Could you not just integrate the dr by dt, integrate this one? But if you integrate
that would give you r on its own then, wouldn't it? And then you could put that into a.
That would tell
No,
you.
it's now that you've explained it, it makes sense to do it the way you've shown me. But in my head, I was just thinking ahead, but I understand why you said how you said it.
If you integrate that, you will find an expression of the radius instead in terms of the time. And that will help you to find, or maybe it would, to find the A by dt. I'm not sure.
I don't think it would. I think the way you've done it makes sense.
Okay. I think you cannot even find the constant of integration. Maybe
No.
you can. I wouldn't do that.
Yeah, that's what I'm saying. I was just thinking.
Yeah, I think you're mixing it with the differential equations that you do in integration, probably. Is this okay, more or less, for everyone? It's clear? Then let me show you another one. I know it's almost 5. Give me 5 minutes and we are done. I'm going to show you one when you have to combine two. Yeah. Let's do one more to practice. You do this one, and then I do one that we have to mix, and then we are done. Radius R of a circular ripple made by dropping a stone into a pond is increasing at a rate of 8 centimeters per second. Can you tell me in the chat, what do you think is this? D what by D what? So what is the number that they are giving me? Look at the units, look at that they say dr by dt. Exactly, is how the radius changes with respect to time. Yeah, the units tell you and they tell you dr by dt. Now, at what rate is the area A enclosed by the ripple increasing when the radius is 25? We are going to substitute R by 25 at the end. What are they asking me? The what by the what? Tell me in the chat, please. What are they asking? The A by dt, exactly, how the area is changing with respect to time. I need another one that connects A, R, or T. What is the other one? The area of the circle. I know the area of the circle, like in the previous question, so they are not telling me everything like if I was a baby, they're just more writing things, but then I know dr by the dA by dr is again 2 by r. How do I connect them? Like I connect them before, it's the same equation, right? So dA by dt is I derivate the A with respect to R, and then I multiply the dr dt. Yeah. So imagine you can cancel these ones. You have the A by dt again. What do you substitute here? 2 pi r on the left is the A by dr, that's the one that they asked me, times 8. Yeah. So dA by dt is pi r divided by 4, and then I substitute the r by 25, or whatever I need to do. Yeah? Yes? Please be careful, because most of the time they're going to give you, instead of the information like this one, that is an example, more like this. So look at the units and read carefully what they are telling you, the rate of change of something. Yeah? Now, let me show you a combination. And that's it. So the volume of a hemisphere V related to the radius is this formula here. So they give me the volume 2/3 pi r cubed. Yeah. What I'm going to be able to find from there? dV by dr if I need it, and it's very likely that I need it. That's why they give me the formula. Total surface area is given by this other formula. So from here, I will be able to find, sorry, 3. I'm going to be able to find ds by dr, yeah, if I need to, that probably I will. Given that the rate of increase of volume is 6, yeah, even if they don't tell me this is increasing volume and in centimeters cubed by second, yeah, so it should be this. Find the rate of increase of the surface area. So now, look how many variables I have. So this is this is not very confusing because it's an exam, it's a question from textbook, but it's confusing because it's the most confusing thing that they can ask you, which is many variables. So we have S, V, R, and T. So we have like lots of things. This one tells me dV by dr, which is what? 2 pi r squared. This one tells me ds by dr, which is 6 pi r. Yeah? And I need ds by dt. Can you try to write one rule that we need? And then we decide if we need another. We are going to be writing 2 chain rules. But can you think we have V, S, T, and R. So how are they connected? What can we write? So we can start maybe writing one for this one, that is the one that we need, and then see how we find another one. Yeah? What would be for this one? Can someone tell me what chain rule I can write for this one? So look what I know. Anatrika, you tell me. You're writing there, so tell me, please.
Is it going to be ds over dt equals dv over dt times ds over dv?
This one has to be the same than this one, so it cannot be dv. So it has to be yes with respect to what?
Oh,
I have one here.
oh, is it over dr?
And then
Is it times dr over dt?
exactly. So that's one chain rule. I need this one. I have this one. And I don't have this one. Where am I going to get that one from? From another chain rule. But now I'm going to use the volume. What can I write? dv by dt. Who can tell me this one? Who can tell me this one? Abby, come on.
Could you have dv by dr times dr by dt?
Exactly. And from this one, dv by dt is 6, they tell me. dv by dr is 2 pi r squared. And I'm going to find dr by dt, making that the subject. I'm substituting it here. Yeah. So to write the chain rule in these type of questions, you have to remember that you're using just some variable in the middle. And to know that variable in the middle, you just go to your question and see what you have. So if I need ds by dt, I need to differentiate ds with respect to something else. And then that something else with respect to t. So this and this must be this and this. Yeah. In this case, I have s in terms of r. So that's what I'm going to do, differentiate s with respect to r. Here is the same. So dv by dt will be dv with something else, and then something else with respect to t. What do I have v in terms of? Again, the radius. So it has to be dv by dr. Yeah. So from here, I'm going to get dr by dt, substitute here, and be able to find the one that they asked me, that is this one. Is it clear? It's a bit confusing. It's not the most common question anyway. Yeah. So I think it's more common to find differential equations and then solving them. So when we do integration, we will work a bit more on this. Any question? We sort of did it in an hour, no? Okay, it's squeezed. I know it's squeezed. Please tell me if you have any question. I will send the recording later. Together with a couple of booklets for you to practice. Yeah, 12 questions if you want. Yeah, 13 questions if you want. And if you have any questions, please tell me. Yeah. I see some of you Wednesday, Thursday, Friday, and there are other masterclasses recorded on the website if someone wants to access those. No questions? No? Okay. Enjoy the rest of the half term. Abby, tell me.
Sorry, with the last one, if you don't have like anything to substitute in, would you just leave it as the equation?
You're always going to have something to substitute in. Answer, Abby. Yeah, so the question is going to give you always, if you have to find the rate of change of something, they are going to give you the information. You can leave the equation, but I haven't seen a question where you have to leave the equation. Yeah, but they are going to give you marks definitely for writing it. So try to write the chain rule, even if you don't know what to substitute. Please write something. The chain rule will be probably enough to give you at least 1 mark. Yeah.
Yeah, thank you.
No problem. More questions? No? Okay, then see you soon. Bye-bye.
Thank you. Thank you.
Thank
Bye.
you.
Thank you.
Sorry, could I